If we have a look at the wall of the small intestine, then it has some similarities to the wall of the stomach. So it's got these muscular layers, it has a circular and longitudinal muscle layers, which we can see here. And also similar to the stomach, its inner lining is thrown into a series of elevations. But importantly, these transverse folds do not disappear with distension. So the rugae in the stomach allowed the stomach to expand in size as more food passed in. These transverse folds, known as plicae, are a permanent feature. They're not lost with distension, and their purpose is to increase the surface area. Increase the surface area of the small intestine, allowing great opportunity for absorption to occur. Similar again, though, to the stomach, we have mucus, the mucosa, which contains these intestinal villi, and these are covered themselves by microvilli, and these again increase the surface area. So the small intestine is long, 6-7 meters long, and due to this plicae, these folds, and these microvilli on top of intestinal villi, we can see that we have a very large surface area. You can see these intestinal villus here. Also, within the wall of the small intestine, we have intestinal glands, and these are found at the base of those intestinal villi. So we have intestinal glands, we can see some here. These are important, they contain goblet cells. These produce mucin, which is mixed and forms the mucus that lines the internal surface of the small intestine. Again, important if some hydrochloric acid was to creep from the stomach into the duodenum, and it also has some stem cells. This is quite a attritional environment, and the food passing over can damage the cells. So we have stem cells for replenishment of the epithelial layer. We also, and these are only found in the duodenum, have what are known as Brunner's glands. These Brunner's glands, located in the duodenum, produce lots of alkaline mucus. This is really important as it helps to protect the duodenum from any acid that's creeping into the duodenum from the stomach. It also helps to inhibit the gastric acid production. So once the food has passed from the stomach into the duodenum is no longer under attack from any acid creeping in. So the wall structure is similar in some ways to that of the stomach, but it's not increasing in that surface area which is lost with distension. This increased surface area is maintained to optimize absorption.